Today's topic is about Telegram based real time coding challenge for object oriented programming. Introduction to the challenge. This presentation introduces a real time coding challenge delivered via Telegram to reinforce object oriented programming concepts. The challenge is designed for undergraduate students in information technology to apply OPP principles in a dynamic interactive setting. Participants solve coding problems in real time using a Telegram bot that sends tasks, validates solutions, and provides feedback. The format encourages active learning, peer interaction, and immediate application of theoretical knowledge. It bridges classroom learning with practical software engineering skills in a familiar, accessible platform. Why use Telegram for coding challenges? Telegram offers cross-platform accessibility, allowing students to participate from smartphones, tablets, or computers without installing heavy IDEs. Its bot API enables automated task delivery, solution submission, and instant feedback, reducing instructor workload. Real-time messaging supports collaborative problem solving and peer discussion through group chats or channels. The informal chat-based interface lowers barriers to engagement, especially for students hesitate in traditional coding environments. Integration with cloud compilers allows code execution and testing directly within the chart window. Core object-oriented programming concepts targeted. The challenge focuses on encapsulation, where students design classes that hide internal data and expose control interfaces. Inheritance is practiced by creating hierarchies of related classes such as vehicle greater than car and truck. Polymorphism is tested through method overriding and interface implementation across related objects. Abstraction is emphasized by defining abstract classes or interfaces for common behaviors like draw or calculate area. Each problem reinforces the is a and has a relationships central to sound object-oriented design. Challenge design principles. Problems are incremental, starting with simple class definitions and progressing to complex multi-class interactions. Each task includes a clear problem statement, input-output examples, and constraints to guide implementation. Solutions must follow OPP best practices such as using private fields with public getters and setters, time-limited rounds, simulate real-world procedure, and improve students' coding speed and accuracy. Automated validation checks syntax, logic, and adherence to OPP principles using unit test. Sample challenge shape calculator. Students are asked to create an abstract shape class with an abstract method calculate area. Constraint classes like circle and rectangle must inherit it from shape and implement calculate area. The driver class instantiates different shapes and calls their methods polymorphically. The Telegram bot sends test cases and verifies output matches expected area values. This exercise reinforces inheritance, polymorphism, and method overriding in a visual context. Like sample challenge library management system. Participants model a library with classes such as book, member, and librarian. Books have properties like title and author, while members can borrow and return books. Encapsulation is enforced by making book availability private and controlled via methods. Relationships like a member has many books are implemented using object references. The bot evaluates whether the system correctly tracks borrowed borrowed data. The bot evaluates whether the system correctly tracks borrowed books and prevents double borrowing. Telegram bot architecture. The bot is built using Python and the Python Telegram bot library hosted on a cloud server for 24 by 7 availability. It receives user messages, parses code submissions, and forwards them to a backend compiler like DJodel or Depletes API. Execution results are captured and sent back to the user with pass or fail status and error messages. User progress is tracked in a lightweight database to support leaderboards and personalized feedback. Security measures prevent code injection and limit resource usage per user. Real-time feedback mechanism. After code submission, the bot runs predefined test cases and returns results within seconds. Feedback includes whether the output matches expectations and hints if logic is incorrect. Common OPV mistakes such as missing access modifiers or incorrect inheritance trigger specific guidance messages. Students can resubmit solutions encouraging iterative improvement and developing skills. Immediate feedback enhances learning, retention, and reduces frustration during problem solving. Gamification and engagement. Points are awarded based on correctness, code quality, and submission speed to motivate participants. Leaderboards display top performers, fostering healthy competition among students. Badges are unlocked for milestones like first polymorphism master or encapsulation expert. Time-based challenges and urgency, simulating hackathon-style environments. Engagement metrics show increased attendance and participation compared to traditional assignments. Integration with curriculum. Challenges alike weekly lecture topics such as polymorphism in week 5 or design patterns in week 8. Instructors can assign challenges as lab exercise, homework, or in class activities. Results are used to identify common misconceptions and adjust teaching focus accordingly. The platform supports both synchronous live class and asynchronous self-paced learning modes. It complements existing tools like GitHub and ideas by offering a low friction entry point for practice. Technical implementation details. The backend uses REST APIs to communicate between the Telegram bot and online code execution services. Code is sanitized before execution to prevent malicious input and ensure system safety. Each user session is isolated to avoid interface between concurrent submissions. Logging tracks submission history, errors, and performance for later analysis by instructors. The system is scalable and can support hundreds of students across multiple sections. Students' outcomes and feedback. Pilot studies show improved understanding of object-oriented programming concepts and increased confidence in writing object-oriented code. Students report higher engagement due to interactive, mobile-friendly nature of the platform. Instructors observe fewer syntax errors and better adherence to OPP principles in later projects. Peer discussions in Telegram groups enhance collaborative learning and knowledge sharing. The, the challenge prepares students for real-world software development practices and technical interviews. Future enhancements and scalability. Planned features include support for design patterns like singleton observed in advanced challenges, Integration with version control system could allow us GitHub this.